Good evening. I would like to briefly go over the executive summary for dissolved organic nitrogen cycling in the South China Sea from an isotopic perspective. So, the area of study the researchers chose to do their findings on dissolved organic nitrogen is in the western South China Sea, as depicted by this graph of indications of their areas used for the research. So I'd like to go through some brief term explanations before continuing on to some figures and why it's important. Uh, DON is often referred to in the article. It's shortened for dissolved organic nitrogen, the most widely available form of biologically accessible nitrogen. DIN is referenced once, but mainly is referenced as dissolved inorganic nitrogen, which is another form of biologically accessible nitrogen, a significant form of nutrients for phytoplankton found during this research. SCS is just an abbreviation for South China Sea, the area again that they use for the study. A biogeochemical cycle is the pathway by which a chemical material cycles. Isotopic composition is what isotopes the material is made of. A lot of the study really references isotopes and how it's impacting the nitrogen cycle and all the different forms of nitrogen and the isotopes they're made of. To continue, TDN is total dissolved nitrogen. A gyre is a large system of oceanic rotating currents. Upwelling is a rising of seawater. And delta 15N is the ratio of two stable nitrogen isotopes. So this figure here goes over the depth profiles of nitrate, DON, um, delta 15N, and all those concentrations. Um, it goes over the nitrogen fluxes in the upper water columns of the South China Sea basins. It's the whole depth profile in those concentrations, uh, showing some kind of comparison of the nitrogen fixation uh, deposits from the atmosphere and how it's impacting the different levels of the ocean that they studied. They have a euphotic zone where most of the DON is calculated. Um, it shows how it all interacts, how you have deposits, um, gatherings of the DON is closer to surface levels and very unlikely to be found below 75 meters, especially below 125. Um, you'll find transfers of nitrogen forms between 125 and above 125. So mainly you'll have um, the depth ranges shown here are mainly for the euphotic zone and the importance of how it interacts with the DOM. Next is the concentration profiles. The profiles of concentration of the delta 15N and multiple other forms of the nitrogens or nitrates. Um, so you have your concentration of nitrate, TDN, and DON, which we've discussed a little bit. Then you got the delta 15N, total dissolved nitrate of delta 15N, and DON delta 15N. And this shows the different interactions between the areas they checked. Um, this is telling the isotopic compositions of the nitrates. Um, all the data shown here is 200 meters and above to surface level of the ocean, the South China Sea that they researched. All the different lines and figures that are seen are the different areas and how they interacted, showing a lot of correlation and similarities across the whole research area. The importance of the nitrogen cycle, including DON. Um, it is proposed that DON plays a role in the nitrogen cycle of the ocean. Studies show that the lateral moves of dissolved organic nitrogen from areas that produce them impact nutrient balance of the phytoplankton um, and all ocean life. This backs the impact of interactions between oceanic areas and biogeochemical conditions. The study shows correlation between the South China Sea, where the study takes place, and other ocean regions, pointing towards worldwide importance. In conclusion, dissolved organic nitrogen is a prevalent contributor of the nitrogen cycle in the ocean. Being aware of the levels of DON and the different levels of the ocean may be a key to better understanding the nitrogen cycle and how it impacts the rest of the ocean. The variance between euphotic DON and shallow subsurface nitrate mirrors the stability between the remaining DON production and consumption. During this study, it shows some areas are known to be more producers of DON, some more consumers, and some kind of have this sort of equilibrium. And it really shows kind of the nature of how all the oceans work off of each other. Um, we can learn more the more we study DON in the ocean. Thank you, and here are my references.